Interquartile range. Our objective? Determine and interpret the interquartile range. Okay, let's remind ourselves the prefix inter means between. So we're talking about working with something that is between quartiles. Okay? Well, we know what quartiles are, the values that divide a list of numbers into fourths, or 4 equal parts. We had quartile 1, quartile 2, which we call the median, and quartile 3. Those 3 values divided our data into 4 equal parts. So what is the interquartile range, abbreviated IQR? Well, inter between quartile, the range of the middle, between quartile 1 and quartile 3, the middle 50% of the observations in a data set. So the interquartile range is the middle 50% of the data set. How do we calculate it? Well, we simply subtract quartile 1 from quartile 3, and that is the interquartile range. This is a fourth measure of dispersion, which we noted was data spread, how spread out data is. However, unlike the range, unlike the standard deviation, unlike the variance, the interquartile range is resistant. In other words, it is not affected by extreme values. The smaller the IQR, the less spread a set of data has. The larger the IQR, the more spread a set of data has. Okay, let's do an example. It's not particularly complicated. We're going to subtract quartile 1 minus quartile 3 and get the interquartile range. In the data set for StatCrunch 3_4_22, which represents the hemoglobin for the 20 randomly selected cats, we determined that quartile 3 was 11.1 and quartile 1 was 9.15. Let's calculate the IQR and interpret it. Okay. The IQR is quartile 3 minus quartile 1. That's not overly complicated. Quartile 3 in our data set is 11.1. Quartile 1 in our data set was 9.15. We'll subtract those 2 things and we'll get 1.85. Okay, so let's interpret this. The range of the middle 50% of the data is 1.85 grams per small d. Sorry about that. Lowercase d, capital L. So, okay. The range of the middle 50% of, I meant to say the data here. Looks like I miswrote. Of the data is 1.85 grams per deciliter. Okay, so it's a little less than 2 grams per deciliter to go from the 25th percentile to the 75th percentile, from Q1 to Q3. Okay, let's summarize now that we learned the interquartile range. This is going to come into play now when the data is skewed. Okay, so we talked a lot about symmetric distributions. When a distribution is symmetric, bell-shaped, normal, we focus on the mean. The mean and the median are the same, so we focus on the mean, and our measure of dispersion, our measure of spread, is the standard deviation. Now, we also talked about data that was skewed left or right. Remember, the tail goes to the left or the tail goes to the right. Well, in those cases, the mean moves. It moves with the tail. The median doesn't move, or doesn't move nearly as much, if at all. So the measure we're looking for when we're talking about skewed data is the median. Okay? And when it comes to the spread of the data, we want to focus on the interquartile range because it's not affected by those extreme values. So again, if it's symmetric, normal, mean, standard deviation. If it's skewed, not normal, median, and the interquartile range.